squared, it'd be written like that as well. So if I square root this side, the other side then is going to be the square root of 3/4, which of course is pi over 3. What's the square root of 3/4? And what's the error you have made? Have we made an error here? We square root something? Thank you, Kim. Hand signals, yeah. Plus minus, yeah. Square root, we don't know which it is. Okay, so there's our, so if we want to find theta, then we have to use sine inverse root 3 over 2, and that's a known angle, isn't it? So where is sine inverse both positive and negative root 3 over 2 in a lot of places, isn't it? Well, root 3 over 2 in general in sine is pi over 3, isn't it? Oh, yes. Pi over 3 is one answer. So here, that'll be root 3 over 2 on the y-axis. Won't worry about the x-axis for this same. This point here is obviously positive root 3 over 2 as well, which is going to be that angle, which is what? 2 pi over 3. But I think we need to do down here and here as well. All 4 quadrants, it could be. What's this angle then all around to here? Well, that's going to be 3 pi over 3 plus another pi over 3. So that's 4 pi over 3. And this would be 6 pi over 3 for full rotation, but minus this one. It's pi over 3. And I think that's 5 pi over 3. There's actually 4 answers. The plus minus is going to be all the spots where it's root 3 over 2 positive and negative. That's what the answer was, I presume. Question 11b. Find the obtuse angles. With sine as pi over 15. So sine is pi over 15. So normally pi over 15 sits here, you know? It's like it's in the first quadrant somewhere. That angle in there, let's say it's pi over 15. Okay, on our unit circle then, more circles ever. There you go, I'm covered. Where else is that going to have the same value for sine? I think it's going to have it in the second one as well, around here. Well, exactly well. In that position. How do I find out what that angle is? From here all around to there. Yeah, so we know this is pi. We subtract this angle in here, has to be pi over 15 as well. So you would, if 15 pi over 15, it's always easy to do that. So 14 pi over 15 will be one of them less. So 14 pi over 15. Find obtuse angles which have the same sign as pi over 15. I think that's the only one. Because the other sign would be negative. There would be a similar value here, but it would be negative, and a similar value here, but it would be negative as well. I think there's only one answer. Was there only one answer in the previous page? I hope so. 11b. 11b. Yes, there was. 45. Okay. Question 12. Find the perimeter area of a sector with radius 11 and angle 63 degrees. Okay. Perimeter and area of a sector. All right, so we got something sector 63 degrees. So this is question 12. 63 degrees here. You know the radius is 11. Okay. What would be the circumference of the full circle? Pi times something. That's the circumference of the whole circle. Righty. How would I get the circumference of a full circle with radius 11? Okay, how do I get the area of a full circle with radius 11?
Like for the angle?
Yeah, 63 degrees. Yeah.
Times.
Pi or squared, yeah. Okay, yeah. So what you've got 63 3/60ths of a full circle and multiply by pi radius squared. The radius is 11, that's 11. I'll give you the area, whatever it is on the other screen. And the circumference of a full circle. So this, you could convert them into radians and use that formula, but I don't think it's necessary. Circumference of a full circle would be the diameter times pi. Because that's times 22, or 2 pi, 2 times the radius, if you want to do that. That's the full circle, and then also multiply by 63 over 360, because it's that fractional circle. Of course, that will only give you this bit. And then you need to add 22 to it to get the perimeter. That'll give you that plus that. So plus 22 will give you the answers that were on the previous screen. So put this way. So this one will give you 66.5. This one will give you 34.1, I think. Well, this calculation there will give you what, 12.1. Does that answer the question, Laura? Please. Matthew wants to do the last one. Okay, yeah, we're going to do the last one. Okay, that's the questions. 13 was not okay. 13 was okay. 13 was not okay. Show that. Fertility. Cos 3 pi over 4 minus sine 3 pi 4 is equal to negative. So that's this quadrant, isn't it? Somewhere here. So 3 pi over 4 will be sitting there. A reference angle. Well, pi over 4 is what in degrees? 45? Pi over 4? 45 degrees. Okay, so that's there. That means 3 pi over 4 is 135 degrees. So 3 pi over 4, it will use your pi over 4 angle here. Get this, these coordinates. Pi over 4 in general is 1 over root 2, isn't it? For cosine and sine. So this is, I know these coordinates. One of these needs to be negative. Which one? Cosine, isn't it? Yeah, cos is negative. Okay. So that's negative 1 over root 2. Minus 1 over root 2, and it didn't equal negative root 2. Obviously not. So we end up with negative 1 over root 2 minus another 1 over root 2 on this side. We leave the right hand side. Common denominator is root 2. I have minus 1, minus 1. I think that's going to be minus 2 over root 2. Yeah. And then I don't like a third in the denominator, so I multiply by a third above and below. Rationalize the denominator, which of course you remember from your work with surds. Yep. So that gives, running out of space, minus 2 root 2 all over 2. And the 2's cancel. Root 2 times root 2 is 2. So 2's are cancel and you're left with minus root 2, which is what you want. Okay. So maybe it was the third thing that caused difficulties. What's the next one? Was okay. So 14. Is there a problem? 14? Someone said 14. No. No. Okay. 15. There was. C and D was it? 14 C. C. Okay. So we know cosine theta to be minus 3/4. And we want to find the exact value of, okay. Pi minus all the angles. So we're going to have to kind of find the angle. Any idea how we go about this? The rest of you must have got it. Draw a triangle. Good place to start, yeah. So if you're not sure, you have to find sine. No, it's still cosine. Okay. Draw a triangle. Say that's theta. This would be 3. This would be 4. 4 squared. 3 squared. 7. Yeah. Okay. That's it. That was from the first two. Yeah, the first 2 parts. Yes, great. Is it inverse? Pi minus. So this is not one of our known angles. Theta lies somewhere here, it says. Yes? Reading it from, 90 degrees. No, it's somewhere here. Here. 90 degrees up to 180 degrees from the question. Theta lies there. So pi minus theta, where's it going to lie? Down here, isn't it? Somewhere. I don't know where. Somewhere. Yeah, but would it have the same cosine value? Should do. Maybe with different signs, but remember all these 4 points with the same angle, theta hasn't changed. All these 4 points with the same angle have the same cosine, it's just positive and negative depending on its position. And I think cosine is positive in that quadrant because x is there. So it's just positive that. So this take away pi is its direct opposite here. So I think it's just 3/4. I hope. Theta minus pi. Makes sense? Based on, no. Think of an angle. Maybe not this one because that's not no one. Let's use the 45-degree angle we had before, or even 60. Let's use 60 degrees. So let's say that was 60 degrees, and therefore that is 120 degrees. So let's say theta is 120 degrees. If I take away 180 degrees from that, which is what I was saying to do, because pi is 100, I end up negative 60 degrees, or I end up in this quadrant, and that's our reference angle of 60. Just going the other way, which is still, hopefully, maybe that made it a bit easier, but maybe not. Okay, yeah. It's all about the 4 positions. Okay. Question 15 then. without a calculator, so 15C, is it C and D? 15C anyway. Cosine 5 pi over 3 minus tan pi over 4. My reference angle for what's pi over 3, what's cosine pi over 3 anyway? Which I know off by heart without looking back. Half? Yeah. And tan pi over 4, the reference for that is 1. That's on the screen. Good. Okay. Now we just have to figure out if this is positive or negative. This is positive or negative. What quadrant does this sit in? So that's 1 pi over 4. Well, we're not sure, but we can check out what quadrant it sits in. That's in here, isn't it? Pi over 4, because 4 pi over 4 would be pi plus the next one. That tells me the tan will be positive. Yay, 1. Okay, so that's positive. And do the same for cosine 5 pi over 3. Let's see what quadrant that sits in. I think it's this one. I think it's in the fourth one. 6 pi over 3 would be here, and 1 less would be there. So cosine there is also positive, isn't it? So these are our two values, a half and 1. A half minus 1 is minus a half. The other one, tan 2 pi over 3, something similar, just square whatever answer you get for pi over 3. So tan pi over 3 is going to be line across from 3. 3 is it? Tan squared should be. Oh, yes, should be 3. And the last one, which we can't see on screen. Find gradients, the measure of theta. Okay, so the first one we have line that goes through the origin, we've got theta here, and we've y is equal to x over 3 as our equation. Okay, that means the slope of that line is 1 over 3, isn't it? I think, or 1 goes up 3. Okay. How would I convert that into an angle? Find the measure of theta. Is there any, so what would that be, sine, cos, or tan? Tan, wouldn't it? So that's the tan of theta is 1/3, because I know it's opposite over adjacent, rise over run. So I just have to use my calculator for that one. You can't get that without a calculator. There's not known angle. There's like a root 3 or 1 or something like that, maybe, but that's, so you just do tan inverse 1/3, and that will give you a theta. And I think we had the answer up there, it's like 0.3 something, was it? I think. Oh, where's the answers? What's it? 0.3222, yeah. It's just the same process for the other one. you want me to, was there a problem with the second part? Because it's, okay. So, yeah. Yeah, it's weird in the book they don't say whether they're calculated or non-calculated questions. And you can probably see by just looking at the answers which one were calculated or base. 12 and 17 were calculated, and the rest of them non-calculated. That's it. Most of these kind of trig ones will be non-calculated. Okay, let's take a look at some functions. All right, so we got the general Sine function in Desmos here. What point will that be where it goes through? 3, 2, and 4. What's it? 4, yeah. And then 6.28 or so here. A little bit. Okay. So on Friday we discussed briefly what would happen if we put the number 2 in front here. What did we see? What did we expect to happen? Let's say we multiply this by 2. Either the y values or the x values. What would happen? All right, let's start at this point here. Is this going to change? Probably not. It's not really affecting the input, the x value.
Is that only the water function?
Yeah, so if I put 2 in front, how much bigger the y value will get? We want the maximum of 1 and the minimum is 9. So max of here is 1.5. So if that's because in our unit circle, the radius is 1, so all your answers are for y, or outputs are going to be between 1 and -1 for sine. If I multiply that answer by 2, the outputs are going to get twice as big. So hopefully that we'll see that happen. Oh, so it still goes through 3.14 and 6.28, but I got twice as big. So that number in front affects the amplitude. So if you by a half, what we expect to happen? Sorry. Yeah, the height of it, the maximum. Okay, so how do we affect this x? I want to move it left or right. What do I affect that? Using something with the angle. So if I move to the right, I would subtract. Yeah. Okay, and let's subtract. First one, the bicycle. Okay, let's just subtract. Okay, I subtract one gradient. So it moves to the right one. Make sense? And then if I also increase its amplitude or its multiply by fronts, it's quite big. Okay, I want to stretch it out. I just don't want to move it, I want to stretch it out. How do I do that? Let's go back to our original. How do I do that? Oriented. I want to move this, I like just make it wider. I want to finish with all the transformations. Right, you know?
Maybe something with like 1 over.
Something 1 over, maybe, yeah. Multiply well, this is like your x, that's a theta, multiply your x by something. So if I multiply it by 2, if I write in the number 2 here in front of theta, so I'm going to write the number 2. Is this going to get wider or narrower? Yeah, I think it's narrower. See, agree, so okay, hopefully, tightens up. Yes. It tightens it up. Very good. Okay, and then if I must remember to kind of multiplying by the x is having obviously opposite effect, so you subtract something that goes to the right, and you multiply it by a large number that actually shortens. Okay. So all these things hopefully we were to well, we started off with these type of words when we talk about trigonometric functions in general. We use this. I've said amplitude a few times. I'm actually saying what it is. The amplitude then is seen on the graph here. It's how high it is. Max its height from the median, like that halfway there. And it'd be the distance between the top one and the bottom one divided by 2. See that, like usually this is the axis. You have the minimum and the maximum point, and then the period of the function is how often it returns, how long before it returns to the same position. So you can see it has to go through a full up, above, and down, and back. But that's in your book, but if you want to take a quick note on this, there are important words. Amplitude and period, you need to know what those are. Functions. Amplitude, you can figure out what max and min point is, but amplitude. Some people think, get confused, the amplitude is the total height from the max and the min. No, it's not. Height from the max and the min divided by 2. And the amplitude, common mistake is half, or sorry, period is half the period, a little period. So it has to reach, does go back to the same position, but also has to come from a full distance. Quick sketch of amplitude. Here, good. Then you try and look at a general sine or cosine function. And how it is transformed by just stuff we just discussed. That's in the book if you can get it. Okay, we want to just write in general some notes on how we would transform the sine function. We have theta. Don't take this down, we just discuss it, and then the proper note will be up in a second. So A, B, C, and D. So tell me about A, B, C, and D, what we think, and then I'll put up the note in a second. What does A control in your words? Amplitude. So it'll affect like the y-axis, I suppose. Okay. All right. What will B control? The width. What word did we just? Okay, the period, yeah. Okay, which will affect the x-axis. What then? C. Left or right? So it'll be what's that word again? Kayla, you know the word. You don't know? Translation, thank you. Translation on the x-axis, is it? I didn't. That's a very weird AN. That's it. That's it.
Where's the end?
I write it so fast, I even do it when I'm trying to slow down. AN, translation. And this is translation on the, oh, there you go, on the y-axis. Okay, let's see if we're right. Okay, that's our notes, what it looks like. If we make any mistakes. Not bad. Yeah, you can. Yeah, it's in the book. It's very useful. I didn't put in the extra set of brackets. That's my mistake. Okay, so in general, yeah. Same for cosine because they are exact same functions. Just one is slightly slid over. Some interesting points down there. The amplitude is the absolute value of A. It made that a little bit complicated. If A was -3, the amplitude would be 3. That's what it's saying. Multiplying by 3. Although it would, if you multiply something -3, it'll flip it across the x-axis. But it'll reach that highest point of 3 still, just a bit later. It's good to know that the period is, in general, 2 pi over whatever this b number is. That comes up a lot, knowing that. So once you see the multiplier here is 2, then you know, oh, 2 pi divided by 2. Okay, it's going to repeat every pi. And we'll look at some of these questions in a minute. Can you remember? Principal axis is y equal to d. We never discussed that. What does that mean? The principal axis is y equal to d. What is d? D is the translation on the y-axis, so it shifts it up or down. Principal axis is this line. So if you move this up, let's say you move the graph up +3, then this line, the halfway point line, will be at 3. Instead of, at the moment, for sine, it sits at 0. But if you translate it up 3, that means its new principal axis will be at 3. The d value is 3. Not very common. This is far more common. This makes more sense. This maybe is better. Okay, so let's look at some questions. Okay. Here are the questions we're going to look at. See all those. Okay, so the previous two changes were okay, right? All right, so let's talk about transformations. I'm going to ask each one of these. You see that? Sine x terminal function. Our new one is y is equal to 2 sine 3x. What transformations have happened?
It's like that.
Like that? The word that vertical maybe?
Yes. Vertical.
Vertical stretch. X scale factor 2. Yeah. Stretch as well. Okay. Yeah. Okay.
By 3. Scale factor 3.
That's right? Yeah. You still call that stretch. You can call it stretch of 1/3. You don't, yeah, you can say skinnier by 3, but vertical straight, 1/3. So it's 3 from here would be the opposite. Same as we did when it was y is equal to x squared. That. All right. Maria, you're up next. How is -2 cosine x?
Vertical structure.
Let's get back to 2. Okay, one more thing that's happened. And negative.
Oh,
It's a reflection of something.
reflection.
What are those? Yes, with all the y values that were, let's say, 2, are now going to be -2. So think about where that's going to sit. Yep. Next one. Ready? 3 sine x minus 5.
Vertical structure.
3, yeah.
And a translation. Like,
5 units with reduced direction.
right.
To the right. Look at the general one. No, down. The x minus 5 difference is if the brackets are there or not. It's crucial. So you see in like this one has the brackets here. This doesn't. It's not with the x. This is just subtraction of the n.
Yes.
So it's this.
Down, like,
Down. All right, Kayla. Part D. Yes. Which direction? Left or right? Yes, right. Very good. Okay, now let's have a look at how we sketch these. I'm going to do, I'll do one. Which one would you like me to do? B? D, okay. Y is equal to, and I'll switch the camera in a second. 1/3 cosine x plus 5/4 plus 1. These will take a while. Okay, let's look. All right. So with anything, you probably should start with the general. If you want to do this and try and beat me to it, go for it. Start in general with the cosine function and then look at how it would be translated. So let's have a little look at the cosine function. Tell me about the cosine function when it hits the y-axis where it starts. Does it start at 0 or 1? 1. Okay. So, and it starts to come down. Hits the bottom point, comes up. All right, so that would be a full period of that. So see here, again, let's back up to 1. Right down here, so this is 1. This is -1. What's this first time it crosses the x-axis at what degree? So this is 0 degrees. Pi/2, is it? Pi/2, which means that this down here would be at pi with it. And this one is at what? 3 pi/2. And then this is at 2 pi. Okay. That's in general what the cosine function looks like. Let's have a think about how this one moves. 1/3. And it's moved. Tell me anything you might think this has done. Any information that you see here, what information do we have? Goes up 1, yep. To the left, pi over 4, yep. And something else. Is it going to get squished? Yeah, so think about the outputs. They would be affected by this 1/3. The y outputs, 1 would then become 1/3. So it's going to get squished. Want a better term. Okay. Oh, let's do some of that. Which one do we want to do first? Does it matter which one we do first? No? No, it doesn't matter? Okay. Tell me which one to do first then. Do the third? Okay. Let's do y is in red. Let's do y is 1/3 cosine x first. All the inputs are going to be decreased by 1/3 in value. Will it still cross at pi over 2 and 3 pi over 2? I think it will, because that's at 0. 0 times 1/3. So it's just going to squish it, not anything. So this is going to be 1/3. This is going to be negative 1/3 for a sketch. Does something like that. Okay. All right. That's y is equal to 1/3 cosine x. Done. Okay. What do we do next? Seems logical. Cosine. I don't need that in brackets. X plus pi over 4, which we say shifts the whole thing to the left. Pi over 4. Oof. Okay. So we probably put in some pi over 4s on our scale. It'll be helpful because they're exactly halfway here. That's pi over 4. That would be 3 pi over 4, 5 pi over 4, and 7 pi over 4. Just for our scale. Right. So maybe start with the where it crosses. That's now going to be here. This point is now going to be here. So I know that that's a point on the graph, definitely. Just shoved across. This lowest point is now going to be here, isn't it? I know this is pretty off. I'll try and make it a bit clear. Okay, the lowest point is now there. All right, this is now moved. Oh, sorry, that quite moved far enough. It's only moved pi over 4, so this point has moved back 1 to here. And this high point here has moved back 1 to here. 1 on my scale. I think. What about here? I think the 1 is like back here, isn't it? Minus pi over 4. So it's gone something like that. It peaks earlier, it starts to drop. Okay. Pretty tough this to do on that one graph. And then to add 1 to it, what should happen? Yeah, it should levitate up. So I'll try and do it in green. Oh. +1. Okay, so that means where the middle point was 0, the middle point now is going to be at 1. So that's way up here on my scale. The same graph is just up here. I need to have 1 1/3 and well, at this point 2/3. That'll be our highest and lowest points. And it shows up. So let's keep it in line. So that's still at minus pi over 4. I don't want to make mistakes. It's the line here. That's that point. Drops down. This point needs to be a line. And so on. This point needs to be a line. Something like that. This point needs to be a high point. Okay. Not easy. And this line is y equal to 1. Have it on. That's my attempt at a sketch. The good thing about these are they're rarely asked for you to sketch it in an exam because you can see why. They're more than likely going to have something like this, to state the transformations, or have a diagram and say what transformations have occurred. Or it'll be a calculator question, and you can sketch it on your calculator and then just transfer it in. They'll say, okay, this graph has been translated this much and vertical stretch this much, and you plot it now. Okay. Maybe, no. So we'll start tomorrow with you guys trying. We have maths tomorrow? Yeah, we do. With you guys trying one of these in the morning. See how it goes. If you're more awake. And yeah, that's it. Don't forget that. Stop recording. Okay, guys, I'll see you tomorrow. Maybe I'll have the meet on anyway for those guys online.
Thank you.
Okay.
Wait, sir, are you gonna send like a recording of this